Hello, and welcome to this presentation, Measuring Power Factor with RTH series oscilloscopes. In this presentation, we'll explain how to measure power factor and related quantities using a Rohde and Schwarz RTH series portable oscilloscope. This presentation assumes a basic understanding of power factor and how it's measured. If you're unfamiliar with power factor, or if you'd like a brief review, you might want to watch the presentation Understanding Power Factor before beginning this presentation. Let's start with a brief overview of Rohde and Schwarz RTH series oscilloscopes. The RTH is a rugged, battery-powered general-purpose oscilloscope. The scope inputs are all galvanically isolated and floating, with protection of up to 600 volts for Cat 4 and 1,000 volts for Cat 3. The RTH also offers an offset range of up to 200 volts. Useful power-related features include an integrated digital voltmeter or multimeter, 37 standard automatic measurements, including power factor and related quantities, and long-term data logging. The RTH can be remotely controlled over both wired and wireless interfaces, and also supports many additional functions, such as measurement of current harmonics, spectrum analysis, mixed signal analysis, protocol decoding, etc. Two oscilloscope channels are required to measure power factor, a voltage channel and a current channel. Voltage is measured across the load, usually by means of a differential probe, that is, a probe that's not referenced to ground. Current can be measured at any point in the circuit, and this is most often done using a clamp-on style current probe. Another method would be using a second differential probe to calculate current by measuring the voltage drop across a known shunt resistor in series with the load. Once we've connected and configured our probes, the next step is simply pressing the Mode Hard key on the front panel and then selecting Scope from the list of available modes. Power factor and related measurements, such as apparent and reactive power, are all made in standard scope mode. Next, we'll go step by step through how power factor measurements are made. On the front panel, hold down the Measure key to bring up the measurement dialog. Here, up to 4 simultaneous measurements can be configured, including power factor and other power-related measurements. Recall that all of these are standard measurements on the RTH. Next, we need to indicate which channels are being used for measuring voltage and current. In this example, channel 1 in yellow is voltage, and channel 2 in green is current. Once these have been configured, power factor is automatically calculated and displayed at the top of the screen. Here, power factor is shown as 572.6 M, which corresponds to a power factor of 0.5726. The M stands for milli. Recall that power factor results are a unitless quantity. Since up to 4 simultaneous measurements are supported, we can also add apparent power S, active power P, and reactive power Q to the measurements displayed at the top of the screen. All measurements are calculated and updated in real time. Let's look at some examples of power factor measurements. Here we're measuring the power factor of a linear load, a traditional 60-watt incandescent light bulb, and a nonlinear load, a 60-watt equivalent LED bulb. Since the incandescent bulb is almost a pure resistance, the voltage and current are both sinusoidal and in phase, leading to a very high power factor of almost 1. And we can also see that the nominally 60-watt bulb is in fact consuming slightly more than 60 watts. The trace on the right shows that the LED bulb draws current as pulses, not sinusoids, so it's only consuming about 9 watts. But this nonlinear behavior also causes its power factor to be substantially lower, at only about 0.56. Time for a brief summary. The standard measurements available on the Rohde and Schwarz RTH series oscilloscopes includes power factor as well as related quantities such as active power, apparent power, and reactive power. To make power measurements, 2 channels and 2 probes are required. A voltage probe, usually a differential probe, is attached to one channel, and a current probe, most often a clamping style probe, is connected to the other channel. After connections are made and measurements are configured, the RTH will display both the voltage and current waveforms, as well as provide numeric results in the form of a table. This concludes our presentation, Measuring Power Factor with RTH series oscilloscopes. If you'd like to learn more about different types of power measurements or Rohde and Schwarz solutions for power measurements, please see the links in the video description. Thanks for watching.